sign. For example, if you are having the single bag, so first, if I am saying that the washing 30 minutes are required, drying 40 minutes are required, and folding 20 minutes are required. So total 90 minutes are required for the single bag. So there are 4 bags are there. So after completion of first bag, all these tasks, then we go for the second, third, fourth. That means after washing, then drying is completed, then you go for the folding. Then whenever you go for folding, then you can put for the loading the clothes for the washing. Like this, you can keep it for that and then start working on that. 1 minute, student, 1 minute. Student, wait for the 2-3 minutes. Hello. Okay. All of you understand this? Shall I go for the next part? So this is a traditional way. Now we move to the next part. Why it is not moved? Now, in a traditional pipeline concept, now we have seen that the first thing is that first bag is that, as I said that it will be required the 30 minutes for the washing, 40 minutes for the drying, and 20 minutes for the folding. So like this task, if you want to perform for the all 4 bags, so like that we can get the 90 minutes for each. So first bag will be required this much time. Then after that second bag. Here first bag will be first. It will be washing, then drying, then fold. Like this, it will be required the 90 minutes. Now second, after completion of the first, we go for the second bag. That is again 30 minutes for washing, 40 minutes for drying, and 20 minutes for the again folding. Like this, all 4 bags we need to take. So if we are start at the 6 p.m. in the evening, it will be required up to the night to complete all these 4 bags, which is we can use the traditional concept of the pipelining. All of you understand this traditional concept, so that I will explain the next one. Now, in a traditional way concepts, first thing is that the another way we can do it. So first thing is that after the washing and the drying, washing will be required 30 minutes and drying will be required 40 minutes. In the single machine itself, means that machine will be perform first washing and then drying. Then for folding we can take it out. Then we can put the after drying, we can put the another bag of clothes for the washing. Then drying. Like this we can perform, and simultaneously we can do the folding. So if you perform like this task, if you skip the folding task, which is a not depending on the means after completion of washing and the drying. So in that uh, way, we will require 3.5 hours for the loading and completion of the task of these 4 bags, which is of only 3.5 hours will be required. If you take the overlapping way, uh, folding and the loading, the washing this task here for the second, it will be done the like that way. That's why it will be required a less time. That is a use of pipelining concept. That means it is reducing the time. Now we will go for the next task. That is, again we have to perform the first of all 30 minutes for washing, 40 minutes for drying, and the uh, holding of clothes, which is required 20 minutes, which will be done simultaneously with the clothes which is we have used for the uh, here drying also, because whenever you are performing this drying, simultaneously you can put the clothes for the washing. If you have that particular machine is having the two compartment, different compartment for the washing as well as the drying. In that case, whenever first machines, first bags clothes are drying, that time second bags clothes will be put for the washing. That task we can do the overlapping way. And then whenever the first machines clothes are dried, we can use the fold that clothes. We can do like task, so it will be overlapping the all 3 operations of the first 2 bags. Simultaneously we can do for the third bag also. So whenever second bags clothes are washing, and second cycle it will be go for the drying, and third case it will be go for the folding. In that case, first is whenever these clothes are third bags clothes we put for the washing, that time second bag clothes will be drying, and here clothes will be drying, and here second bag clothes will be we are folding, and then we go for the third bag drying also, sorry, folding. Like this task we can perform. So first thing is that whenever we say that the task which is overlapping here, that is the first one is washing, drying and folding. Like these 3 tasks will be performed, but of the first bags, but simultaneously we are applying second bags clothes also. Whenever first bag clothes are drying, that time we are putting the second bag clothes for the washing. Whenever first bag clothes are folded, that time second bag both clothes are drying, and lastly we are drying the folding the second bag. Now for after completion of the second bag, we go for the third, which is used for the washing, third bag, then drying, which will be done simultaneously with the second bag. Whenever second bag clothes are the drying, then third bag clothes is going for the washing. Then second bag, B bag clothes are going for the folding. That time third bag clothes are drying. Then again third bag clothes are folding. Now last one is whenever we go for the fourth bag, whenever fourth bag clothes are going for the washing, that time third bag clothes are going for the drying, and whenever third bag clothes are going for the folding, that time fourth bag clothes are the drying, and lastly we go for the folding the task. That means there are different way we can perform the pipelining. How we can do the overlapping operation, that is depending upon that, which is I have shown with the help of the 3 different examples. Now we move to the next example. That is we have seen for the traditional way. Now if you want to use the ideal pipelining of the computer, in that the first of all, that means we need to perform the first of all instruction should be fetch, and after that instruction we need to execute. Sir, whenever you are performing sequential operations, in that first instruction is there. For that we have considered only these two steps, fetch and execute. So first instruction is fetch and then it will be executed. Then second instruction is fetch, then it will be executed. Third instruction is fetch, then it will be a fetch. Abhishek Borse, mute yourself. I am hearing the background noise. Now, here simultaneously we are executing the instructions, instruction 1, 2, 3. So in that instruction simultaneous executions, there are steps are there. First one is fetch and second one is execution. So after completion of fetch and execution step of the first instruction, we cannot go for the second instruction, fetch and execution. So next thing is again, whenever we are fetching and executing the second instruction should be completed, then only we can go for the third instruction, fetch and execution steps. And it will be required in terms of the some time will be required. That is a sequential execution of the instructions. But whenever we want to execute the parallelly execution of the instruction, that concept is used in a pipelining. So in this diagram, here it will be basic idea of the instruction pipeline will be mentioned here with the fetch and execution cycle. So here cycle clock cycles are mentioned 1, 2, 3, 4 in with respect to time, and instructions are specified here 1, 2, 3, which is we need to perform parallelly. So in the first instruction, the first instruction should be fetch in the first cycle, which is mentioned here like this. So first instruction is fetch in the first cycle. So first instruction, whenever it is executed in the second cycle, that time in a parallel pipelining processes, second instruction is going to fetch. Simultaneously, first instruction is executed. Then whenever first instruction completed its execution, that time second instructions is going for the execution in a third cycle, not second cycle. Okay. So in second cycle, first instruction is going to fetch and first instruction is executed and second instruction is going to fetch. In third cycle, only the second instruction is going to execute it. Now in a third instruction cycle, the third instruction is fetch, and after that fourth cycle, the third instruction is going to execute it. That means in the third cycle, second instruction is executed as well as the third instruction is going to fetch. Like this, these are the parallel operations at a time, two operations which will be done in the cycle 2 and 3 only. So in if you consider the 3 instruction, that means in the first cycle only fetching is done, and last cycle, fourth cycle, execution of third instruction will be done. But in between cycle 2, first instruction execution and second instruction fetching will be done. In cycle 3, for second instruction execution and for third instruction fetching will be done. Like this, the idea of instruction pipeline is implemented in the instructions. All of you understand this? All of you understand this? Shall I go for the next part? Students, all of you understand this? Okay. So that we will go for the next part. Now, whenever we want to use this pipelining concept, we need to use the cache memory concept. What is the role of cache memory in case of parallel pipeline? That I'm going to explain first, and then actual pipelining concepts I will explain. Now, whenever we are using the pipelining stages, which is we are expecting to complete one in a one clock cycle only. But the clock period which is we have allocated, which is long enough to complete the slowest pipeline stage first and then the fastest, that will be happen here. So slowest pipeline stage to be completed. So faster stages can only wait for the slowest one to complete. Since main memory is very slow compared to the execution. If we are having the instruction, so if you want to fetch the instruction from the memory, as we have seen that it is a slower. So for each instruction, we need to fetch from the main memory and provide to the pipelining. So when in that case, pipelining is almost useless in that case. To avoid that things, to slow, it will be slow the pipelining concept. So to avoid this, we have used the cache memory, which is going to hold the current data. Through that, we can reduce the fetching time of the memory. That will be done with the help of the cache memory. So with the help of the cache memory, we can increase the performance of the pipelining concept. So that in that pipelining performance, the potential, how we can increase the performance of the pipelining. That means, first of all, we need to add the number of pipelining stages. More number of pipelining stages should be added. So it will be increase the speed of the pipelining, and same task will be completed within a short time. So, but for that, whenever we are performing this number of pipelining stages of the particular instructions, number of instructions, in that case, no interrupt should be occur in that program, and it will be not going to hamper the throughput of the program execution. Here, interrupt is nothing but the one type of service routing which will be called by the processor to stop the current job and take the priority job. For that purposes, interrupt is used. That will be in concept used in a microprocessor. And throughput is nothing but the how much time is required for the execution, successful execution of that particular program. That is nothing but the throughput which is required for the instructions. And now next thing is that whenever we want to calculate the performance of the pipelining, here clock cycles are mentioned 1, 2, 3, 4, 5, 6 with respect to time. Clock cycles are always respect to the time, and instructions are mentioned 1, 2, 3. Like these instructions are given. Now, whenever we want to implement the pipelining concepts and where we need to calculate the performance of the pipelining. So first instructions, as we have seen that the instruction is mainly divided into the two parts. First one is fetching that particular instruction, and second one is execution of that particular instruction. So first instruction is there. In the first instruction, the as I have mentioned in the previous 50, fetching and execution, these two parts I have mentioned. Now, whenever we are executing the instructions, first of all, instruction is going to fetch. After fetching instruction, operand is that instruction is decoded. After decoding that instruction is going to execute it. After executing that instruction, result will be stored on the particular device that is called as a write back operation, which is mentioned by the W. So that for the each instructions here it is mentioned that F1 means first instruction fetching cycle, D1 means the first instruction decoding cycle, fetching first one is, F means fetching, D means decoding of the operand, E means execution of instruction, and lastly write back operation. Like this, each instruction cycle, execution cycle, these four operations are mentioned. Now, whenever we are performing these operations, it will be required a 4 cycle for the first instruction. Same thing for the second cycle, third cycle, and fourth cycle. Then, whenever we want to increase the performance of the system, whenever first instruction is fetched, then after fetching, it will be go to the, in a first cycle, only first instruction is going to fetch. That operation will. Now in a second operation, second cycle, first instruction is decoded. That time from the instruction will be fetched from the memory. Again, whenever you go for the third cycle, the fetching second instruction is also, this task is going on, but that time first instruction is executing. Then whenever first instruction is result is stored, write back, that is the write back operation is done. Still that first instruction is going to fetching, that operation is going on. And again we go for the fifth cycle, still that second instruction is going to fetch. Then in this first instruction fetching cycle, all the task is completed, then second instruction fetching task is completed in a fifth cycle. So from it will be start from the first second cycle to the fifth cycle. Total 4 cycles are required for the fetching second instruction. Now we move to the second instruction decoding operation, that will be done in a 6 clock cycle. Simultaneously, in that whenever second instruction is going for the decoding, that time we are fetching the third instruction. Now in a 7th cycle, second instruction is going for the execution, that time we are fetching the decoding the third instruction. Now whenever we go for the next 8 clock cycle, that time second instruction data is write back, that time third instruction is going to execute it. This task is done parallelly, which is shown here. So, and after that third instruction is result is write back. Like these 9 cycles are required for the performing these 3 instruction cycle will be required. All these 9 cycle for the execution. So which is mentioned in this diagram, which is given the title instruction execution steps in successive clock cycles. Now, if I'm saying that if you are using the idle period for this call or bubbling for the particular instructions, or sometimes it may be happen the whatever task we want to perform which is not received within a particular time, that time we need to send that task n number of times, which will be to help of the F, as I explained. F is for fetching, D is for the decoding, E is for the execution, and this W is for the write, which is mentioned here. Then clock cycles are mentioned 1, 2, 3, 4, 5, 6, 7, 8, 9 with respect to time. So in the first page, first instructions is going to fetch in the first cycle only. Okay, which is mentioned here. Now in second cycle, first instructions, we can say that our second instruction is F2, means second instruction is going to fetch. That time first instruction means here F1, D1, E1, W1, which is respect to the first instruction only. Then F2, D2, D3, D2, E2 and W2. This E operation will be performed by the instruction 2. Then instruction 3, fetch 3, decode 3, execution 3, write 3. Like these operations are mentioned, same operations are used here. So first instruction is fetch in the first cycle only. Then in second cycle, second instruction is fetch. First instruction is going to decode. This operation is going like this. See, first instruction is fetching in the first cycle. In the second cycle, first instruction instruction is decoded. In the third cycle, first instruction is executed, and in fourth cycle, that first instruction result is write. That will be that task will be done here, which is mentioned here. Okay, here. Now, what happened whenever second instruction is fetched? This will be a missing the cache rate. That means that instruction fetching is not received from the main memory within a allocated time. So remaining cycles of the third, fourth, and all these three for the second F2, it will be go idle. Again, you are trying for the third cycle, fetching the second instruction. Again, this will be go idle. We cannot receive that instruction particular time, so that the parallel task should be performed. So again, it will be go idle. Again, in the cycle F2, cache goes idle, and it will be not receive that fetching instruction within that particular time. Again, it goes the idle. Now, in the fifth cycle, what happened? this second instruction is going to fetch successfully within a given time slot. So that in a 6 clock cycle, that second instruction is going for the decoding. In 7th cycle, it will be go for the execution. And in 8th cycle, that second instruction is going for the write back operation. Like this, it will be done. Then third instruction is fetch in the 6 clock cycle. 7th cycle, that third instruction is decoded. 8th cycle, the third instruction is executed, and in 9th cycle, it will be done the write back operation. Here, these in between cycle 2, 3, 4, 5, 6, even 7, some cases are going idle because of the data fetched from the memory which is not received within a particular time to perform that particular task. So for each processor, the function which is we are performing, for that we require the cache memory concept. That's why the some cycles are going here idle, which is explained with the help of this example. All of you understand this? Why decoding of the second operation is not done in a third cycle? Okay. Ashish Barge is asking. Here, good question. In second cycle, he is saying that the decoding is not done. Why decoding of second operation is not done in third? Okay. Here, second instruction is fetch in a second cycle. So here we should have a decoding of D2 should be here, but which is not done here. Why? As I explained that whenever we want to fetch the data from memory, always that data from the memory we need to fetch for the particular instructions. So it will be fetching from the memory. As we know that the main memory is slower. To make it fast, we use the cache memory, which is going to access the faster data. Because of that, the what happened in second instruction decoding, it should not go for the second instruction decoding. Why? The first, that is the second instruction, is fetched in a second cycle. But for example, for fetching, it will be required of 5 seconds. For example, okay, it is required less than that. It is in milliseconds only. For your understanding, I am telling that. But it is not received that fetching of data from main memory to the processor, which is not done within a 5 seconds. It will be required more time. So that cycle will be, because of that, the third cycle, fourth cycle, fifth cycle of second instruction, it will be go idle. Again, third cycle, we are fetching the second instruction. Again, here it is not received within that particular time. So these cycles go idle. Again, fourth cycle, we are try to fetch the second instruction from the memory. Still, it is not possible. Again, these cycles are going. And what happens? For example, in fifth step, that fetching of data from the main memory of second instruction is done successfully within a given time or less than that time. So that in the fifth cycle, that second instruction is fetched and it will be go for the next stage for the decoding, next stage for the execution, and last stage for the write back operation. Like this, it will be performed. Now understand, Ashish? Okay, but burst time is factor, isn't it? Yes, burst time factor is matter because the how much time is required for the fetching particular data, depending upon that, the pipelining performance will be considered. That is called as the throughput. Time required for the execution or by required for the executing the particular operation. That is nothing but the burst time, or you can say that the throughput time. Now, I need to calculate the performance of the pipelining. So that, for example, if I'm saying that I want to use the instruction load X is nothing but the R1 comma R2. That means content of R2 register should be loaded into the R1 register. That task I need to do. The standard hazard is that which will be what are the causes occur in this, which is we are going to see here. Here clock cycles are mentioned here. cycles are 1, 2, 3, 4, 5, 6, 7, which is mentioned here. Then instructions are mentioned here: I1, I2, I3, I4, and I5. These are the instructions. So his figure indicate the effective load instruction of pipelining with respect to the time. So first thing is instruction is going to fetch in the first cycle, which is mentioned here. Fetch, first instruction fetching will be done. In second cycle, first instruction is decoded. That time, second instruction is going to fetch. These are the two parallel operations will be done in process. Now, in a third clock cycle, first instruction is going for the execution, second instruction is going for the decoding, and third instruction is going for the fetching the data from the main memory. Like these three tasks done parallelly. That is a pipelining. Again, when we go for the fourth clock cycle, first instruction is going to write back, second instruction is executed, third instruction is decoded, and fourth instruction is going to fetch in the fourth cycle. Like these four simultaneous operations are done, which is we can say that the parallelly in the fourth cycle, first instruction writing, second instruction execution, third instruction decoding, and fourth instruction fetching. Like these operations are done. Now in the fifth cycle, first instruction is completed, so these are not going to do anything. Now second instruction is going to M2. That is nothing but the you can say that in this the instruction is not going to uh, perform the write back operation. This cycle is fetching data memory that is executed on the memory, that it is mentioned here. So third cycle execution is done and fourth cycle decoding is done. After that, when we go for the sixth clock cycle, second instruction data is write back, which should be right here in the fifth cycle. But this task is not completed. Because of that, it will be required a more number of cycles. So it will be moved to the sixth clock cycle. That's why the write back operation of this after execution, one cycle should be required for each. Not necessary every time. It may be required one or more than that cycle for the execution of the particular operation, or it may be that in between that interrupt is occur, so that that particular instruction execution required more time. So the second instruction, instead of completing the cycle, it will be go to the sixth clock cycle. Now, Sumit Birarda, please switch off your mic. Sumit Birarda, roll number 101. All of you can see my PPT. You can see now my PPT. I muted the all. Students' PPTs are visible to you. Yes, thank you. Now, like this task will be done here. Now, whenever we go for the next cycle, here, seventh cycle, third instruction is writing, fourth instruction is executing, and fifth instruction is decoding. Like this, parallelly, we are performing these three tasks. Now, we go for the next part, how we will increase the performance of the pipelining. The pipelining does not result in an individual instruction, but it is executing faster, and it will be required to increase the operations. 1 minute, student. Now, whenever we are using the individual pipelining executions, it should be done the faster way. So throughput should be increased. That is, the throughput is nothing but it is measured that the rate at which instructions are going to complete its execution. That is nothing but the throughput. That is nothing but the time required for the execution of the particular instruction. Now, whenever we are seeing that the number of example for the pipelining stall, which will be causes the degradation of the pipelining the performance. So we need to identify what are the different hazards are there, which will be causes the pipeline stall, to find out the way to minimum impact on that. So what do you mean that hazard, which is I am going to explain now. Pipeline hazard is nothing but there is a situation called hazard where where the processor or instructions are preventing to that particular instruction stream to perform some certain task executions. That means that execution is not done in that particular dot. For example, if you are saying that the fetching of the instructions also I have shown, then decoding of the instruction which is not done that particular time, or execution of the particular instruction is done not done in that particular time, or we want to write that particular result of the instruction pipelining which is not done in that particular time. That is nothing but the pipelining hazard which will be required for, which is going to preventing the next instruction stream for the execution during the design cycle. So there are three types of hazards are there: structural hazard, data hazard, and branch hazard, which is used for that purposes. मी थोडा वेळ बंद करू का माझं लेक्चर? Now, third type of hazard are third type of hazard is there are three types of hazards are there. First one is structural hazard. So in that structural hazard, sources conflict when the hardware cannot support the all possible combinations of the instructions simultaneously. 2 minutes, students. Okay. Structural hazard. Structural hazard is nothing but the sources of conflict when the hardware cannot be support all possible combination of instructions simultaneously. That means structural hazard. That means whatever hardware is designed for that parallel processing, in that source, whatever source data we are providing for the instruction pipelining, which is not going to support it for that. Meaning of this for that structural hazard is that, for example, you have designed the pipelining for the only instructions operations which is going to perform only integer operation, but we have provided some floating point operations which is not done here. That will be happen here. Now data hazard is nothing but the instructions depends on the result of the previous instruction. Data hazard means a dependency is there. Previous instruction results is required for the next instruction. For that, we can take the best example. If you want to perform the addition of the arrays of the n number of arrays are there, and we want to find 5 array elements are there, and you need to add and display the result. Or for example, you can say that the you want to calculate the of the particular student, 5 subject mass you want to add, find out the percentage. So first 2 subject mass is added, then third, fourth, fifth, like this. In that case, data hazards are going to occur. That is, a instruction depends on the result of the previous instruction. In that case, data hazard is occur. Now third type of hazard is branch hazard, which will be occur that the instruction that changes the program counter content. In that case, branch hazard is going to occur. That means the whatever sequence is given for the branching operation is not done according to the conditions. That time branching hazard is going to occur. Then whenever we are using the pipeline stall, the hazard is going to prevent the instruction steps from happening, and the processor pauses the execution steps until the hazard is resolved. That means this is hazard is going to prevent. Means these are the reasons through which we are not going to perform the successful pipeline. It is going to stop until these hazards are not going to solve. We cannot perform the pipelining. It is going to and then it is going to restore. Then whenever pipelining stalls, slow the execution of instruction, but do not prevent it from the execution correctly. That will be happen here. This is end of content. Any doubt in this? This is end of third unit. Any doubt, please put it in chat box. Any doubt? No? Okay. Before going to the fourth unit, I checked the some students' paper. In that, I found that the 95% students have done mistake in the single and double precision problem solving. They have not solved properly. In tomorrow's lecture, I will take that first. In the tomorrow's lecture, single precision and double precision. I will explain first because 95% student had done the mistakes in that. Okay. And then I will start the fourth unit. Is it okay for all? Okay, just now I checked the 25 papers. So in that I found the all students had done like that only. Okay, thank you.